code, I want to explain a concept that's important to understand. How does this shift actually work? So there's basically two ways of doing it. The first way is we can take the number of letters in the English alphabet, which is 26, and we divide that by 2, which is 13, and we have to shift 13 places. So basically, let's actually take a smaller number that's also even to understand the concepts. I'm going to pick 6. So I'm going to write down 6 elements. I'm going to draw a halfway line right in between them so you guys can understand and see how it's working. So for these 6 elements, the first way is we can say that, well, 6 divided by 2 is 3, and I'm going to shift 3. So if I'm ahead of this halfway breakpoint, I'm going to need to shift backwards, because if I shift forwards, I'm going to end up out of bounds, right? So say I pick 4, I can't shift 3 spaces because 4, 5, 6, and then I'll end up out of bounds right over here. But I can shift backwards 3. So if I'm at 4, if 4 is my initial starting point, and I'm going to shift 3, so I'm going to go 1, 2, 3, and I end up at 1. The second way to do this is to wrap around. So imagine these numbers, instead of being on a straight line with a wall at the end that's stopping you, or a wall behind it from stopping you from going backwards, it's essentially like a circle. Like you would have all these numbers over here, and you would have 1, 2, 3, 4, 5, 6. And if you would have 8, it's the same thing. So you could either go forwards, you could either go backwards, and you'll end up with the same result. So over here, let's pick the same number, 4, right? So instead of the logic before, what we said was, if we're ahead of the breakpoint, we're going to move backwards, and if we're before the breakpoint, we're going to shift forwards. We're going to wrap. Okay, so watch. So 4, right? And we want to shift 3. So let's wrap. So 1, 2, wrap around 3, and we end up at the same point. Okay, this is called modular. We're going to use the modulus operator that JavaScript has. And I believe there's also something called modular arithmetic, which is a similar concept. So now let's actually increase this. Let's do 8. I'm going to write down 8 elements. Again, I'm going to write a breakpoint right in between the middle. Okay. So now let me start with 8. Okay. And I'm going to say that we're going to shift 4 because 8 divided by 2 is 4. There's 8 elements. I'm not saying 8 because the number 8, it doesn't matter. Even if I would have picked 5, I would still shift 4 because I'm doing it by the total number of elements that I have. So let's pick 8 right now. And obviously, if I'm going to use the first method, I can't go out of bounds because I have a wall here and a wall behind. So I can't really go out of the bounds of what this container is. But I can go backwards because I'm ahead of this breakpoint. So I'll go 1, 2, 3, 4, and I end up at 4. And this is my point right there. Now, imagine it's a circle, right? And then I can actually go around. So 1, 2, 3, 4, and I end up at the same. All right, let's pick 10. I'm just doing this to show you that it's the exact same thing. It doesn't matter how many numbers you pick, it's going to work out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And let us draw a wall between them. Okay, let's pick a number before the breakpoint. So remember, the logic was if we're before the breakpoint, before the halfway point, we're going to move forwards. And if we're ahead of the halfway point, we're going to shift backwards. So 10 elements, I have a total of 10, divided by 2 is 5. So I have to shift 5. So let's pick 3. So this is my chosen pick 3, right? I want to shift from 3. So the first way is, right, I can't go backwards, right, because I have something blocking me. So what I can do is I can shift 5 forwards. 1, 2, 3, 4, 5. I end up at 8. Now imagine it's a circle again, and I'm going to wrap around. So 3, 1, 2, all the way around. 3, 4, 5, and I end up at 8. Same result, okay? In the first way, I'm going to show you the code how to do it with the first example I showed, and the second way is by wrapping around. All right, great.
Okay guys, JavaScript Algorithms and Data Structures Project, Cesars cipher. So, the most widely known ciphers is a Caesar cipher, also known as a shift cipher. In a shift cipher, the meanings of the letters are shifted by some amount. A common modern use is the rot13, where the values of the letters are shifted by 13 places. Thus, A corresponds to N, B corresponds to O, and so on. So write a function that takes an encoded string as input and returns a decoded string. All letters will be uppercase. Do not transform any non-alphabetic characters, spaces, punctuation, but do pass them on. So this, it wants it to return free code camp, but this is what we have over here. So let's copy this. Oh, and first we need to look at the ASCII chart, and this is a numerical representation of what each character on your keyboard is. So let us see over here. So for the uppercase characters like it wants, we have a value between 65 and Z is 90, okay? We have 26 letters in the English alphabet. If we have to shift them by 13 spaces, and it just so happens to work out that 26 characters divided by 13 is, 26 characters divided by 2 is 13. That is going to work out in our favor. So we're going to use that. So let us copy and paste this over here. That's the function that we wanted. And what we're going to do is, the first thing we want to do is, let's get an array. So we're going to declare a variable called char array, and we're going to set that equal to str dots. We're going to call the split method on it. It's an inbuilt JavaScript method. And let's just console.log that. Let's see what we got. Okay, so that's our character array. So with each letter in here, in this character array, we want to do something with it, right? So we want to actually shift it by 13 places, and we're going to return it. Okay, so how are we going to do that? So we're going to do it as follows. First, let's declare a variable. We're going to call it ascii array, and we're going to set that equal to the character array dot map. An ASCII array isn't actually the ASCII characters. We're going to return a shifted version of the ASCII characters more accurately. So this variable name might not be so accurate, but I'm just going to use it for now because it's going to return this. We're going to have an array of shifted characters. Okay, so let us map it. All right, and map. That's a callback function. X represents each character inside, so S, E, R, so on and so forth. So what are we going to do with each letter? Well, we're going to return is in range. Is it in the range? Is it in the range of 65 to 90? So let's declare this constant is in range, right? Arrow function. What are we going to do with this? Okay, so if we're going to use this JavaScript method, this will give us the character code, the ASCII code. It accepts a character, and it's going to give us the ASCII code. So X, not accepts, I'm sorry, we're going to call this method on a character, and it will, on a string, and it will character, and it will return the it's going to return us what the value is, a numeric value. Okay, so if it's between greater than 64, why 64? Because we want 65, because the range is 65 to 90. So, and if it's, and also if x dot car code at, if it's less than 91, so between 65 and 64 and 91 non-inclusive, so that's the range of 65 and 90. So what we're going to do is, so first let's see if x dot, first what we need to see is if the character is, if the value is, we have to see if it's less than or equal to 77. Why if it's less than or equal to 77? Well, let me explain. The reason is because if it's less than or equal to 77, we can safely add 13, and it won't go outside the range of what we want it to be. It won't push past the range, because remember, there's a range. We can't go outside of. We don't want to return a character that's not an uppercase character. And remember, the range was between 65 and 90. So from here, what we can do is we can safely shift it forward. Okay, so if it's less than or equal to 77, so we're going to return, this is the string object dot from car code, and this accepts this from car code method. What it's going to do is it's going to accept an integer value, a numeric value. But what we're going to do is we're going to take we're going to take the character code of what this x was, and we're going to add 13 to it. And it takes this numeric value and it's going to return us a string, a letter that we want. Shift it forward, right? If it's not less than or equal to 77, we have to do the opposite, right? Because if it's less than or equal to 77, we can safely shift it. We can safely go forward 13 places. But if it's greater than 77, right? So else, it means it must be greater than 77. So what are we going to do if it's greater than 77? We're going to have to shift it backwards. You're going to have to go backwards minus 13, not 134, minus 13. Right? Otherwise, if it's not any of these, we just need to return it as it is, right? Because it said don't do anything with it if it's else we're just going to return x. Okay. So let's see what happens over here. Oh, and let me actually say shifted. Okay, so we get free space code space camp, right? So, but it doesn't want an array. The challenge wants the actual string converted, right? So we're gonna have to convert it back. So let us implode this string. So str.join. We're going to return str. Get an error. str.join is not a function. Sorry. ascii.join. No, I'll try it. Okay. Yeah, free code camp right there. Okay. So let us Control-C. Make sure it passes this test. Okay, shiver me timbers.
Okay guys, before we go into the wrapping method, I wanted to shorten this code and show you how I could clean it up a bit and make it a lot shorter than it is. So I'm going to start with this function over here. And what I want to do is, let's first comment this all out. So let's try to make it one line. We're going to return, right? The first one is the string split over here. Let's copy that. So we're going to split this string that we're getting into an array, right? And we're going to map, call the map method on that array. For each element in that array, pass it to this callback function, which was is in range x. Then we're going to join it. We don't need to save it to a variable. Let's just skip that dot join. Save that. Sorry. There we go. Now it should work. Let's check this out. Hold on 1 second. This is commented. Comment that, and then console.log this. Okay, free code camp. Very good. Okay, so now we can get rid of this. Let's get rid of all this. Now we have a one-line function that's very good. And let's actually turn this into a const rot13. Let's make this into arrow function. Dat. And then let's get rid of this. Let's get rid of this, and we'll put this on one line. And 10 equals, let's delete this. We can get rid of the return statement. It's implied by itself. Let's try it now. Let's clear this. Very good, okay. So now we've shortened this to one line. And let us see if we can do similar for this over here. So that's what we're going to do. Okay, let's comment this. We're going to return. Let us first make a variable. Carval. We're going to call it charval. And this is just going to hold that for each element in the array. We're going to car code at. So we're going to return. What we're going to say is charval, is it less than 64? And is charval greater than 91? All right, if that's true, so let's just return x. Just return the value as it is. Otherwise, charval is charval less than or equal to. So if it's not true, so charval is less than or equal to 77, is it? So let's string dot from car code charval plus 13. Otherwise, string dot from car code charval minus 13. Okay guys, this is the nested ternary and it's in the free code camp curriculum. I will provide a link in the description for review. Let's save that. Let's see what happens over here. Okay, so it did not give me what I want. It worked for all of these letters. For
It worked for SERRB. So these are all capital letters within the range, but it didn't work for the space. All right, so because it doesn't make sense. It's not less than 64 and greater than 91. It is, or it is. Yeah, so now it's working. Okay, so let me explain why. So with the space, so the space is the value of a space. Let's look at the ASCII. It's right here. So the value of a space is 32, right? So 32, right? So 32 is 32 less than 64, right? Let's actually go back to the way it was before so we can see. I'll explain why. So 32 is less than 64. So this will be true, right? So this side is true, and charval and is 32 greater than 91. That's false, right? So it's false. So true and false is going to default to false because true and false is false, right? So true and false is false. So is false true? So is false is true, print X. So it's not true. So then it's not true. So it's automatically going to go to this statement. So it's going to evaluate here. So is 32 less than or equal to 77? Well, it is less than or equal to 37. So what it's going to do is it's going to add, right? Right? Because 32 is less than or equal to 77. So we're going to add 13. So what's 32 plus 13? So I can tie to JavaScript developers do not have to know arithmetic. 32 plus 13, 45. Okay, so yeah, so remember we had this. So what's the value? What is 45? It's that character right there, that dash. That's why we're getting that. Very cool. All right, so I've explained that. And now the next step is to explain the wrapping method and how that works. So we're going to get into the last part, which is how to wrap around using the modular arithmetic. All right, so for now, we're going to comment this, right? And what we're going to do is we're going to check that it's in the range that we want, which is between 65 and 90 inclusive. So that would be if x dot car code at, well, I could just use this actually, charval. So we're going to use charval. So if charval, if it's greater than 64, and if charval, if it's less than 91, right? So that means it's in the range, right? So what are we going to do here? We need to do some modular arithmetic. So first, otherwise, if it's not in the range, let's just do what we said before, right? Which is just going to return x. Okay. So if it's in the range, what we can do is we can return. So we want the string, right? Dot from car code. So let's do charval minus 65. Charval minus 65. Let's add. Okay, so why are we doing minus 65, right? So the reason we're doing minus 65 is because let's just actually make it easier for ourselves when because we're starting at 65. So
we want to go all the way back to the beginning. Like we're basically doing a reset. So we're resetting to the beginning, which is 0. So let's reset everything. So instead of from 65 to 90, we're going to do 0 to 35. Okay, cool. So let us do, yeah. So now remember we want to shift forward, right? 13 places, right? And then here's the trick. So this is the wraparound part. So we need the modulo operator right over here. Right, let us modulo. I'll explain how this works. You guys are going to see it. There's 26 letters in the alphabet. And again, we need to reverse what we did before because we went back 65, right? So now we need to reverse it. It's going to do plus 65. Right. All right, cool. Let's see if this works. Nope, no, it's not good. Hold on. Let me fix this over here. Some mess I made with the parentheses. Plus 13. Here's this one right here. Try that again. There we go. Free code camp. Okay, so let me explain to you how this exactly works, right? Let's do this arithmetic out. Let's actually pick, remember, so we're going through 65 to 90 inclusive. So if we pick a number that's clearly before the break point, like say we pick a value of like 67, right? So let's do the calculation, right? So say we have 67 plus 13. Sorry, 67 minus 65 because we're resetting it, right? So 67 minus 65 is going to be 2. And then we want to add 13. $15, right? So we're gonna have 15, right? And then how many times does 26 go into 15? Right, well, it doesn't go into 15 at all, and we're gonna have 15 remainder, right? So we're gonna have a 15 remainder, and then if we add 15 to 65, right? Well, that's essentially what we wanted to do before, right? Because what we said in the first case was that if we were before the break point, we're going to add 15, right? So that's all we're going to do. So if we do 65 plus 15, you're going to get your result. And that's the same as before. What we said was that if we're before the break point, we add 15. And if we're after the break point, we're going to subtract 15. So either way, it's the same thing. Right now, I'm going to show you another case. Let's say we pick a number that's clearly after the break point, right? So let's say 85. So 85 is clearly after. It's after that break point of 77, right? So 85 and right, 85 minus 65. Let's actually delete this. 85 minus 65 is 20 plus 13. 33, right? 33 mod 26. Okay, well 26 goes into 33 once, and that's 27, 28, 29, 30, 31, 32, 33. 27, 28, 29, 30, 31, 32, 27. Cannot do basic math. That's the problem over here. Okay, so 26, 27, 28, 29, 30, 31, 32, 33. Yeah, so 7, like I said before. So it's mod, so we're going to have a remainder of 7, right? So what's 7 plus 65? 7 plus 65 is 72. All right, so we said 85. So what we said was, if we're ahead of the break point, right, we're going to subtract 15.
There you go. So it's the same result either way. That wraparound is going to work, right? And you've seen it work over here. All right, there we go. Okay, thank you for watching, and I will provide you a link in the description of all this code. Very cool. All right, have a good one.